Well, welcome back. This is Unit 1.2, Units and Conversions. And in your textbook, this is going to be page 78 through 95. Please read that. It will be very, very helpful. All right, so we're going to first start talking about dimensional analysis. And dimensional analysis is a method that allows you to easily convert from one unit to another using conversion factors. A conversion factor now is a fraction or a factor that's written so that the denominator and the numerator are equivalent values, but just in different units. For example, we know that 60 seconds is the same thing as 1 minute. So these are equal. 60 seconds is equal to 1 minute. But we can write this as a fraction, one over the other, two different units. And because this is equal, we can write it with seconds on top and minutes on bottom, or we can flip it where minutes is on top and seconds is on bottom so that we can use it however we need to use it in our problem. And I'll show you what I mean by that in just a moment. Okay, but these are two things that are equal. So if I take some number, say, I don't know, just 45, and multiply it by 1, like if we multiply 45 by 1, then we're going to get 45. So this is the same thing as 1, since these are equal to each other. This is 1, so we're not changing the value of the number, but we use it to change the units. Okay, and so that's what dimensional analysis is. Okay, so let's look at an example. So we purposely set up the units to be opposite one another in this example here so they can be cross-canceled out, which leaves the unit of centimeters, which is what we want because we're taking 2.4 inches and we want to convert it to centimeters. So this right here is a conversion factor. These two things are equal. 2.54 centimeters is equal to 1 inch. But this is in the imperial system of measurement, inches, and this is in the metric system. Now this right here would be given to you. Okay, this would be supplied for you. And we'll see an example of that in just a second. So we take, and there are certain steps that you need to follow. And I am going to just jump forward here, right here. So these are steps that you need to follow, and these are in your reference materials that are on Google Classroom. So if you follow these 5 steps and you ask yourself these questions, you can do any of these problems that we're about to do. Okay, so let's take, for example, the 2.4 inches and let's convert it over to centimeters. And I'm going to show you how this works using those questions that I just showed you. So question number 1 is, what unit am I trying to get rid of? Well, the answer to that is inches. Question number 2, where can I put that so that it can cross cancel? Well, that kind of gives you a hint and it kind of tells you where you can put it because cross cancel mean they have to be opposite each other. So if this is on top, over here on this one, it needs to be on bottom. So we're purposely putting inches on bottom so that these two units can cross cancel. And number 3, write a conversion factor where the values are equivalent. So this conversion factor is supplied for you. So we can go from inches to centimeters. So we're going to put 2.54 centimeters is equal to 1 inch. Okay. What can I cancel? Well, inches cancels inches. So you have centimeters left. And it says, am I to the unit that I need to be for my answer? And the answer is yes to that. So it tells you to do the math. So when you're doing math with fractions, you multiply straight across. So we're going to multiply 2.4 times 2.54. Okay, and you're going to get 6.1. And then we're going to multiply 1 by 1. That's going to give us 1. So 6.1 over 1 is equal to 6.1. And then we just carry over the unit that we have not canceled, and that's the unit for our answer. So 6.1 centimeters is equal to 2.4 inches. So what we've done is just taken inches and converted it over to centimeters. Okay, and dimensional analysis is a method that we use in almost every aspect of chemistry, the calculations that we do chemistry. So it's really, really important to know what you're doing on this. All right, so I'm going to move some of these out of the way so that they're not distracting. And we're going to solve this problem. And this problem says, how many centimeters are in 1.00 yards? Okay. So what we're going to do is, it says in our reference materials that we're going to take the given and we're going to put it over 1. So that's how we're going to start this out. So our given here is 1.0 yards. So I'm going to take that and I'm going to put it over 1. We're going to make it a fraction. Putting it over 1 doesn't change anything. Okay. So the next thing that I'm going to do is I'm going to add a multiplication sign because we're going to multiply by a conversion factor that's written as a fraction. So I'm going to put times and then I'm going to draw a line just like that. Now I'm going to start asking my questions. Question number 1, what unit is it that I want to get rid of? So the answer to that is yard. We want to get rid of yard. Question number 2, where can I put that unit so that it cross cancels? Well, cross cancels, I had to put it here. Okay, and I'm not putting any numbers in. I'm just answering the questions, and all of the question asked me was about yards. Okay, was about the unit. Question number 3, write what conversion factor can I write where the values are equivalent? Okay, so we're trying to get to inches because here's our conversion factor that's given to us. 2.54 centimeters is equal to 1 inch. So can we go straight from yards to inches? Probably not, okay? So what can we go to? What do we know about a yard? Well, yards are made up of feet or a foot. So now how many feet are in a yard? 1 yard is made up of 3 feet, or 3 1-foot measurements. Okay, so the next question is, what can I cancel? Well, look, we set this up purposely so these two things can cross cancel. So I'm going to go ahead and cancel those. Now the next question is, am I finished? Do I have the unit that I need for my answer? Okay, so here it's asking how many centimeters. So the answer to that question is no. Now, if the answer is no, it tells you to go back up to step number 1. So we're going to go back up to step number 1. Step number 1 is, what unit am I trying to get rid of? So I need to add another multiplication sign and another line here. Okay, so the answer to that question is foot. That's the unit I'm trying to get rid of. Where can I put that? Question number 2, where can I put that so that it cross cancels? Well, the answer to that question is here, cross cancel. Question number 3, what conversion factor can I write where the values are equivalent? So what's equal to a foot? Okay, and remember, we want to try to get to inches because we're trying to get to where we can use this equation, this equivalent here, as a conversion factor. So do you know how many inches are in a foot? Yes, we do. That's easy. 12 inches are in 1 foot. Okay, and so now the next question is, what can I cancel? Well, we set this up purposely so that we could cancel the feet or the foot. Question number 5, am I finished? Do I have the unit I need for my answer? So the unit that I have here is inches, and I want centimeters, so that's no. If you answer no, what are you going to do? You're going to add another multiplication sign, and you're going to add another line because you're going to go back up to question number 1 and start this process all over again. Question number 1, what unit am I trying to get rid of? The answer to that is inches, because that's the only thing you have. Because look, these have been canceled out. So they don't exist anymore once they're canceled. So the only thing we have is inches. Question number 2, where can I put that so that it cross cancels? Well, the answer is here, cross cancel. So it has to go in the bottom here. So question number 3, what conversion factor can I write where the values are equivalent? Well, here we go. Now we have a value where we're using inches that's equivalent or equal to something else. So I'm going to put centimeters up here. Now remember, I could have wrote this any way I wanted, but I need to make sure that inches is in the bottom to cross cancel. So that means centimeters has to go in the top. So 1 inch is equal to 2.54 centimeters. So keep these together, right? You wouldn't split those numbers from those units. Okay, so what can I cancel? Inches is going to cancel inches. We purposely set it up that way. You're going to be left with centimeters. So question 5, am I finished? Do I have the unit I need for my answer? The answer to that is yes. So it tells you now to do the math. So remember, fraction times a fraction times a fraction. What you do is multiply straight across, both the top, straight across on the bottom. Okay, so 1 times 1 times 1 times 1 is 1. So it's going to be some number over 1, which is just going to be the number that we have on top. So let's grab your calculators and let's calculate this with me. 1.00 times 3 times 12 times 2.54. You're going to get 91.44. All right, is that my answer? All right, if you said no in your head, then you're absolutely correct. That is not my final answer, because remember, we have to look at the significant digits that are in the problem. So I'm going to go ahead and erase this so I can clean this up. Okay, and so we are multiplying here, multiplying and dividing. So that's what we do most of the time in chemistry. And the rule says if you're multiplying or dividing or both, if you multiply or divide at any point in your problem, then you're going to round your answer to the least number of significant digits that you have in your problem, not counting the conversion factors. So we can't take the conversion factors. It's only the supplied data, the measured data that's in your problem. So here's the only measured data that was given in our problem. So it's 1.00. That's 3 significant digits. So we had to round this to 3 significant digits. There's 1, 2, and 3. So we're going to look at our 4. Does the 4 round this 4? The answer is no. So our final most accurate answer is 91.4 centimeters for this particular problem. Okay, that's dimensional analysis. That's all there is to that. Okay, and so remember, this previous one that we had, we just needed to add that 1 conversion factor there. But since you are using these steps that I gave you, you just keep using those steps and using those steps over and over again. You keep adding fractions that you multiply by another conversion factor until you arrive at your needed unit that you want for your answer. Then you're done. All right. Now, as I mentioned in your reference materials, I've included these steps for you to do dimensional analysis. And if you memorize these steps, you'll always be able to complete a conversion. I don't give you these steps when we take a test or a quiz. So this you have to commit to memory. Okay, so make sure that you get these written down. Make a note card, print off these reference materials that are on Google Classroom and have those with you the whole time you're doing these problems, because the more you look at them, the more you use them over and over and over, then the sooner you're going to learn them. And this works for every single problem. I've never had a problem where I was trying to convert or use dimensional analysis that this did not work on. Okay. All right, so converting with the metric system, we talked about this in class, but I'm going to go ahead and also talk about it here. If there's anything I say here that I didn't say in class, make sure you write it down. As introduced in the last section, I talked about the metric system in 1.1. It's in the base 10, so everything is in powers of 10. Okay, below is this full list of the metric prefixes. Keep this handy so that you can refer to it during the school year. Okay, so for this section in 1.2, we're doing these problems. You're probably going to refer to this a lot, but during the school year, you know, when we're using just these 6 that I told you about with a line next to them, these are the 6 that are you have to memorize for the class. Okay, and then the ones in gray right here are the ones we use 99% of the time. So if we ever get to a problem where we do need to use one that's not familiar to us, then you'll know where this list is and you can know where to go for it. Okay. All right. So base units right here, it says base. So here we have all of these metric prefixes and the value for that prefix that all go to this base. So remember, a prefix is a stem, a word stem that you add to a base word. And for the base measurements in chemistry, for length, it's meters, and that's a lowercase m is the symbol. For mass, it's grams, that's a lowercase g. For volume, it's liter, and that's an uppercase L. And for time, it's seconds, and that's a lowercase s. Okay, so what you do is you take one of these prefixes and you add it to the base unit. For example, kilometer or kilometer. Okay, that's very common measurement in the metric system. So we see here that a kilo is 10 to the third. That's its value. So what is 10 to the third? 10 to the third is 1,000. So 1 kilometer is equal to 1,000 meters. Okay, 1 kilometer is equal to 1,000 meters. So there we have a conversion factor that you can use in any dimensional analysis problem where we have to go from kilometers to meters. Okay, so we can do the same thing with these down here that are below the base. So let's take millimeter, for example. So 1 millimeter is equal to what? Well, what's the equivalent, the numerical equivalent for milli? It's 10 to the negative third power. So 10 to the negative 3 is going to be 0.001. Because remember, taking our base unit is 1, okay? And negative 3 means you're moving the decimal this way. So 1, 2, 3. So it's going to be 0.001. So this is 0.001 of the meter. Okay, so 1 millimeter is 0.001 meters. Okay, and we can use this conversion factor here in any dimensional analysis problem that we have. So we can solve all of these problems. We can say, exactly how many micrometers are in a zettameter. Okay, we can figure that out now because we have these and the equivalents. All right, and next is I want to talk a little bit about a derived unit. A derived unit is composed of more than one unit. We saw this on one of our warm-up questions where we have, like, say, for example, density, which is something that you learned in junior high. Density is mass divided by volume. So if we have a mass of, say, 10 grams and we have a volume of 5 milliliters, so we take and divide this. 10 divided by 5 is 2, okay? And then what's our unit? Well, this one was in grams and this one was in milliliters. Now, it's grams over milliliters. So the question is, can we reduce this or simplify this at all? The answer is no, we can't. So that's our answer here. 2 grams per milliliter is the density. Okay, and this is a derived unit. It's derived by dividing 10 grams by 5 milliliters. Okay, so it contains more than one unit, and it's a derived unit. And that happens a lot with a lot of different units, just not grams and milliliters. So say, for example, this is, if this was a liquid, let's just say it was a block, like a block of aluminum, a cube. So there we would use cubic centimeters because we would measure length, width, and then height. And we'd get the volume of this cube. So that would be cubic centimeters. So if this was 10 grams and the block was 5 cubic centimeters, because this is a solid, okay, then we would get 2 grams per cubic centimeter, which is grams per cubic centimeter is a derived unit as well. All right, and the last thing I want to talk to you about is temperature. Temperature is a measure of the average kinetic energy of the particles that are in a sample of matter. And in the United States, we measure things in Fahrenheit. But in science, we do not use the F word. And I talked about that when we did our first lab. We always measure temperature in Celsius, okay, degrees Celsius. But there is another temperature we use in the metric system, and that's Kelvin. And we don't use Kelvin until we get to gases, but it's a very simple conversion. You just add 273 to the Celsius temperature. So 0 degrees Celsius is going to equal 273 Kelvin. You just add 273 to 0. That's all you do. Now, you may have heard this before, but there are no negative numbers in the Kelvin scale. So the lowest temperature is 0 degrees Kelvin, and that's what we call absolute zero. Absolute zero is 0 degrees Kelvin. All right. Well, that's it for this video. So make sure you slap that like button right across the face. Make sure that you like and subscribe and give me a thumbs up.